Awesome. Let me get oh, oops. It looks like I got the notice that the sharing is like disabled for me. Oh yeah, there it is. Thank you. All right, let me get that. All right. Does this look good for everyone? Everyone see this? Awesome. Great. So hello everybody. My name is Mora Labisi and I am a software engineer at Starbucks. And I graduated from Cal Poly Pomona in May of 2020. It wasn't really graduation though. It was just like logging off of like a Zoom call for the last time. So didn't really get to do anything fancy, but that's fine with me. All right. So, and today I'm so happy to be here to talk to you about how Starbucks is using GraphQL to get you coffee faster. And if you don't understand what GraphQL is or anything like that, no worries, because there's also going to be a little mini intro to GraphQL as part of this talk, as well as a little intro to APIs and what those are. So, before we dig deep into it, let me first tell you a bit about some of our cool stats about Starbucks technology. So I'd like to do a quick little survey. How many of you have the Starbucks app on your phone? And virtual people too, you can raise your hand too, or give me a little thing. Cool. Okay, nice. Keep that up. That's some job security for me. No, but seriously. So you are one of the millions of people that are showing up on this slide here. So I'll just do a quick rundown. There's almost 50 million average monthly mobile orders, and 25% of our orders are mobile orders. So while you might be familiar with going through like the drive-through or like walking into your local Starbucks and ordering there, a big chunk of it, a quarter of our orders are coming from the mobile app. And all of the people who use the apps, you included, make up about 23 million users of the mobile app. So Starbucks really touches a lot of the customers in a way that you kind of don't think about. Like I remember when I was considering Starbucks as like a tech company, I was like, what? Like, do they want me to be a barista? Are they confused? But like, no, there's a lot of tech going on here. This is just for the mobile app. We also have the website and in-store technology. So yeah, and I see, yeah, we use the mobile app to skip the lines. Yeah, that's a very underrated use, I think. But yeah, Starbucks uses technology in every part of our business. We have a huge tech team with about 1,500 tech employees. So that's about one third of the staff at the Starbucks headquarters, which is in Seattle. And today we're just going to highlight one small slice of our technology, which is the Starbucks mobile app. And we have almost 20, yeah, we have almost 23 million customers, and that was just in a 2 week time frame, I should clarify. So this is like a lot. This is only like 2 weeks. So you can kind of extrapolate that. It's touching a lot of people. So real quick, for the agenda, before we dive in, I'll just give you a quick overview of the topics we're going to talk about. So first, we'll take some time to understand the definition of an API and get an idea of what it is. And once we have that, we'll get a condensed history of the API as we know it today. And then from that point, we'll take a look at GraphQL and how it can be used when creating and interacting with APIs. And then we'll explore the benefits of using GraphQL and see how we use it here at Starbucks. So, jump in first. What is an API? So, this kind of like spoiled what it like stands for, but I'm curious if anyone actually understands what an API means. Like, let's do another survey. Raise your hand if you've heard of an API. All right. And then keep your hand up if you're like super confident to like what an API is and like what it does. All right. Okay. No worries if you're like going up and down. Hopefully, by the end of this, you'll have a good idea. So, as it says here, API stands for Application Programming Interface, which really does not like mean anything. So, I'm going to tell you what that is. So, it's kind of like a faceless website, but instead of like displaying the pretty like UI and the pictures and the design, it's just the raw data that actually like powers like dynamic websites. So for example, let's say if you want to load like your grades on like I don't know, Blackboard or something. So Blackboard looks, I mean, it still kind of looks, I don't know if it still looks bad, but like I never liked the UI of Blackboard. But let's just say, of course, there's a team there that designed the UI. So let's give them some credit. So they're what we consider the client. And the client is kind of like the front end or like what the website looks like. And then when it comes to the actual back end, that's where all the data, like all your grades are stored. That would be like in a database. So that's like the back end. And then in the middle of that is the API. So the API is how the client accesses the server or like the back end. So you might hear me use it interchangeably, server, back end. They're kind of the same thing. So the API is in the middle and it gives you that raw data. So Blackboard will get the raw data from your like professor's place where they upload your grades to like a database. And then the API itself will kind of package that all up into just the raw data. And the most common format of the data is JSON or JavaScript object notation. Oh, you stopped using Blackboard, actually? Good for you, because it was horrible. So whatever the replacement is, I hope it has a better user interface. Canvas, okay. Oh, I don't know. Is Canvas any better? I don't know. But so yeah, so Canvas will take your grades and it will be in JSON, JavaScript object notation. So you might have heard that. It's just like the raw data. It's like a key and a value pair, just a list of those. And then the Canvas like front end team will take that data and transform it into like the table or like whatever kind of UI they have there. And like if you have to do like discussion posts on Canvas or anything like that, that's also the same thing where you're the one entering data and the client will send that to the database through the API. So the client is saying like, hey, add this to the database. And you would send that, you type it in the fancy text box and you can do formatting and stuff. But when you send it over, it goes in that raw data. So probably like HTML or like a HTML form, or maybe it gets transformed into JSON or whatever. So that's kind of what an API does. So again, it's really just data transferring from a client to a server, and then also vice versa from a server to a client. And the API just kind of lives in the middle. So if we want to talk about kind of the motivation behind APIs, so kind of like before APIs were a thing, there were millions, well, probably like hundreds, and then it became like millions of servers and clients, which is complicated to say the least. And it brings up quite a few questions for developers of both the servers and the clients. So the first one is, how should the World Wide Web be organized? So beyond just the concept of servers and clients, front end and back end, developers need to know how they should actually kind of be designed and organized, like who's in charge of what data, who's in charge of like who's responsible for like cleaning the data before it gets sent, or should like the client like clean the data before it gets sent to the server, things like that. And that leads us to the next question, which is, what format should requests be made in? So again, client-side developers, if they're requesting data, they need to know how do they format their request, and what should they expect in return, which leads us to, how do developers know how to build their web services? So web services are servers or backends. So again, when it comes to organizing that data, they need to be mindful of how the clients are going to use it and how that data is going to be like kind of packaged to be the most efficient, because it's being sent, over a network. So you have to kind of think about, how do I like write my code in a way that it'll output data in a way that's really transferable and readable on the client side. And there's also, how do clients know how to make requests to a specific server? So we have the general idea of like APIs, which are like a contract saying like, this is the data you can get and this is the data you can send. And how do we just know the specific, for like one specific server, what are the accepted protocols and procedures? So like one protocol is like HTTP. Totally forgot what that stands for, but that's probably the most popular one. Does anyone know what HTTP stands for? I'm something protocol, I'm guessing. Wait, what? I think I heard someone.
Hypertext transfer protocol.
There you go. Hypertext transfer protocol. A+ for you. And whoever else said it that I didn't hear. Sorry. But yeah, that's one of the protocols. There's also I have more acronyms: SFTP, FTP, and like those are for like files, I think. There's one for like emails. There's all these different protocols, basically. And I'm sure you can have like a whole trivia game of all the different protocols. But HTTP is the most popular. That's the one you see in your browser. TCP, yeah, TCP, HTTP, HTTPS, all of that. So yes, those are just like protocols. And when you build a server, you have to think of like, how is the client going to reach my data and like what protocol should they use? So you're getting like down to the networking kind of layer of things. So another consideration is, what should the client expect in return from the server? So client code for handling the server's response can't be written until the client knows what is the format that's going to be given. And this gets a little, it seems simple, but this gets a little complicated, I think, especially in the industry when things are moving so quickly. Sometimes the format that the server says they'll give you the data in changes while they're like working on it, and things start breaking. And that's why you see like apps are always being updated. Like you will never see an app stop getting updated. And if it does, the company is probably like done, because there's things that are constantly changing. And the even just a single line of data, like the name of a field, can like break a whole app. So that is one very important consideration. And lastly, how should clients and servers interact with each other? So again, beyond just the protocols, like when should a request be sent, or like when should a client expect to receive something from a server? All of that needs to be standardized. And that's where APIs come from, the motivation behind that. So web and mobile apps use APIs all the time. And just taking a brief look at the Starbucks app homepage reveals the significance of APIs in the software we use every day. So for example, looking at the Starbucks homepage here, if we look at the top header where it says, "Good afternoon, Dana," stole this screenshot from my teammate Dana, shout out Dana. So how does the app know Dana's name, for example? Well, that comes from the user info API. So the user info API has more than just your name. It has like your birthday, when you joined Starbucks, rewards, like your address, things like that. And then we get all of that data just to get your name. So that comes from the user info API. And then another cool API is like the number of stars you have, or like your like tier in terms of the rewards you can redeem. So that comes from the loyalty program API. And this is a big API that's used beyond just the, oh, sorry, I think I hear a bit of an echo. I want to make sure that's not coming from me. One second. Testing, testing. Okay, cool. Yeah, so the loyalty program API is a huge one that's used beyond just the mobile and the web app. It's also used like in the store when you scan your phone when you're like placing an order in person, if anyone still does that. I use the app all the time. So, but the loyalty program API is connected to even the stations, like the point of sale station that the baristas use. It's all connected through this loyalty program API it's like a giant, like, and this is just about the US one. There's one for like different regions of the world too, because the way you earn stars differs depending on like what country you're into. So that's like a huge like team that's like split up into all these different services and things, but that's the loyalty program API. And then there's also little fun tasks you can complete to get bonus stars. And that actually comes from the offers API. So if you tend to order a specific drink a lot, you might get like a little challenge to like order this 3 times in 1 week and get bonus stars. And that comes from the offers API, which is managed by the MarTech team, or marketing technology. So if you also have a mind for business and marketing, I think MarTech is like a cool other side of technology at Starbucks, because they come up with all these campaigns on how to like get users interested and keep users on the app. And then you have the tech where you're coming up with the best way to make things engaging and work well. Most of all, you want to make sure it works. So yeah, this is just a cool view of just 3 APIs that are used for just this one screen on the, and this is not even all the APIs on this one screen, but these are just some 3 we wanted to highlight. So, and real quick, we can take a look at the evolution of the web API. So beginning in 1991, interactions between clients and servers on the web were built on a library-based API called libwww. And it was literally like a real library. So like if you go to a library and you want a book, you have to know like what exact shelf the book is on, and like you have to look through like however the library is organized and find the one book. So this API kind of like setup requires you to know exactly where to look in order to retrieve the data you wanted. And this introduced complexity and ultimately hindered performance, because the like your source code is actually having to like make multiple calls. If it gets it wrong, it has to like recalculate things just to try to find one single resource. So by 1993, it was common for organizations and individuals to duplicate and extend libwww in order to add features and customizations. And it was at this point that the underlying APIs of the web became network-based, which meant that the API itself would make all the necessary connections on behalf of the client. So it's kind of like having a librarian walk you through the aisles directly to the book that you're looking for. Then in 2000, 7 years after the popularization of network-based APIs, Roy Thomas Fielding, he introduced the design behind the modern web API in his UCI dissertation. So he was from academia, actually. And his approach focused on combining the key concepts of software and networking to create a style of APIs that emphasize organization and convenience. So REST APIs are kind of what are most commonly used for most websites and applications, with GraphQL coming shortly up in popularity, because that was in 2012. So GraphQL was actually created by Facebook. So the engineers at Facebook were working on the mobile app for the homepage, or like the wall is what it used to be called. And they were really concerned about the mobile app because that was back in the time where like 5G wasn't a thing. I don't even know if 4G was a thing in 2012. So people had really bad connection on their phones. And REST APIs, we'll see later, are not really optimized for if you have bad connection or if you're barely on your phone and like all that data, you don't want to have to wait for it to get to your phone. So they designed the GraphQL to be network-based and designed with mobile apps in mind. So in the world of the internet, what changed significantly between 2000 and 2012? That would be smartphones. So people were accessing the internet on their phones way more. And in 2008, the iOS App Store launched with 500 apps. And as of 2020, there are almost 5 million apps available for download between Android and iOS app stores. So this was, the age of the mobile browser and mobile apps. So again, this, brings new challenges. Like if you have bad service or if you have low storage on your phone, if you have too many like apps running, all these different considerations. And yeah, in 2009 is when the Starbucks mobile app was released. And I wish I had a screenshot of like what it looked like in the beginning. I'll have to like find that because I'm sure it was very different. But yeah, we'll get like super kind of technical now, and kind of see what do we mean when I say like a REST API, and how the requests are kind of not optimized for the phone. So we'll kind of look at that here. So let's say I'm making a website that relies on Yelp, and I want to display a business's name and phone number. So big businesses like Yelp have so much data. They probably have hundreds, if not thousands of APIs. So the first challenge is you need to look through Yelp, like their developer portal, and like if they have documentation or things like that, and find the one that returns data about a business. So let's say I eventually find this URL, and I'll kind of explain what's going on here. So this is an HTTP call. An HTTP call is made up of, you have a verb. So that's kind of what you're doing. The main ones are get, post, delete, put. So get is obviously retrieving. Post is usually like for adding something or creating something. Delete is removing something. And then put is usually updating something that's already there. So you have your HTTP verb, and then you have the URL, or the URI, which is like Universal Resource Identifier, or URL, which is Universal Resource. I'm going to guess link. We already know I'm not good at acronyms, but something like that. So you have to get that specific link. And then you're able to kind of filter with something that is known as a query parameter, or something that's part of the actual URL path. So here that would be the business ID. So if I put my business ID in, it'll return all the data about the business. So this is a REST API, which means what you get, you can't really like change the structure. You're kind of stuck with every single field here. And that might not seem like a huge deal. You might be like, yay, like the more the better. But some API responses can get huge. And when you're on a phone, if you don't have great service, that could take a really long time to load. Or you might have tons of like pics and videos saved on your phone, and that data is going to fill up a lot of your storage space. So again, all we were looking for was just like maybe like the name of the business. And instead we had to kind of wait for this whole JSON object to be built. So yeah, this is what JSON looks like, those keys and values. And yeah, we only wanted the name and we got all of this. So that brings us to what is GraphQL? So GraphQL is a query language for APIs and data sources. So I'll kind of dig back into that, starting with the end of the name, QL. So QL stands for query language. And you might be familiar with other query languages like SQL or SQL, which is a query language for relational databases or databases that are shaped with a table that has rows and columns in it, and then they have relations between tables. So SQL is common for databases. Well, GraphQL is the query language for APIs, and APIs are more than just databases. Remember, they're kind of in the middle of the client and then the database, or even another kind of service could be another data source. So it could be like a REST API or another GraphQL API, or straight talking to a database, any of that. So the GraphQL is just a kind of interface for all the different types of backend services you can have. And then graph, so the graph part of GraphQL is just how the data is organized and processed. So the way that the kind of a relational database has, tables, and if you've taken like the database class, you'll know that there's the concept of like keys and foreign keys and having to like relate all these different tables and stuff. So GraphQL instead does it kind of like an org chart where you have like, this is one concept and it's kind of linked to this concept, and it's not super complicated. You can like nest objects. So that's kind of why it's GraphQL, because it's kind of a more straightforward representation. And we'll go ahead and get into a cute little example of GraphQL that'll help you visualize it. So let's picture this. It's the end of the week and you've got some errands to run. You got to pick up some dinner. You're thinking pizza, but you don't want to eat pizza the whole time. So you want to get some groceries too. And then finally, let's say you need to pick up your dry cleaning that you've been putting off. So that's a lot to do, especially since you're a student, you got stuff to do. You got to go to your CSS meetings. You got to get good grades. So what if you got a personal assistant? So in that case, that's like the picture on the right. You would write up your list of errands, pass it off to the assistant, and they'll pick everything up and return it to you in a nice, orderly way. And although it's wishful thinking to get a personal assistant as a college student, as a developer, GraphQL is kind of like that personal assistant. So it kind of goes in the middle of you and what you need, and does it all for you in a nice way. So again, if we look at the REST implementation, again, you have to know the specific URL, what that URL takes to kind of filter the results. And then you got to look through the response and kind of pick out what you need. With GraphQL, it's a little different. So GraphQL's or Yelp's GraphQL API actually looks something like this. So let's say again, all we want is the business's name and phone number. So the request would look something like this. The URL is just one common URL. So this one is api.yelp.com/v1/GraphQL. So there's no need to say like /businesses/business ID or whatever. It's the one GraphQL API. And then within the request is where you specify what data you're looking for. So in this case, we're still looking for businesses, but this is now kind of within the request. And it's kind of a more straightforward way to filter, because you can kind of pass it in, look kind of like a function where you're saying like, for business, I want to get a business whose ID is this. And then from that business, I only want the name and the phone number. So it's really straightforward. You're telling the server exactly what you want. And in this request, the the response is going to look just like the request. So we'll kind of see if I show you the response. So yeah, it looks like this. So on the right, you see that the server has responded with only the info we requested for that specific business. So it's fast and it cuts out all the extra data that we didn't want, especially from like when you compare it to the REST response. You got to sift through all that versus this. We get exactly what we wanted. No need to wait for the whole response to be put together. So real quick, if we just take a look overall at the differences between GraphQL and REST. So first, its architectural focus is client-based. So here, the client means the user of the website. And again, the clients are able to request any data from the server, which is exposed through that one single endpoint. Whereas REST, on the other hand, is server-based. That means the API team is determining what data the user gets. When it comes to data representation, for GraphQL, the response is just a giant JSON object, but the query is structured exactly like the responses. But on top of that, responses only contain the data that was requested in the query, nothing more, nothing less. REST APIs are a little more versatile because they can return other data types beyond JSON. So they can return like an actual picture or like video file, or maybe even like XML or whatever. Like they can return files of different extensions, whereas GraphQL is, again, just the kind of JSON, although you can have like links to external sources if you wanted within like the key pair, the key value pairs. And GraphQL, we call the different actions you can take a query, a mutation, or a subscription, which kind of mirrors the kind of typical REST API operations, which are create, read, update, and delete, or CRUD. You might hear it be called CRUD. So you can see that GraphQL has a little extra one, subscription. So while queries for getting data, mutations for adding or deleting or updating, subscription is kind of like a live kind of connection between the client and the server, where updates are just pushed constantly between the two. So this is really good for kind of like chat rooms or like something where you want to get like live updates, versus like in a REST API, like you would have to use a different protocol for that, or like you have to use like WebSockets and like set up a whole kind of different thing there. So subscriptions really help kind of minimize all the extra work you have to do there. And then now, real quick, the benefits of using GraphQL. I'll kind of go through this one a bit quickly because I do want to get to how Starbucks uses GraphQL, and also I want to have time for questions too. So real quick, I'll just say clients, again, only need to make one call to the GraphQL API, and they can fill up that request with all kinds of things beyond just the business. They could add like more things they want to query in there, and it would all come in one call. They don't have to call like the slash businesses endpoint and then call the slash, I don't know, reviews endpoint. Everything is just in one call. And then unlike REST, GraphQL will make the necessary backend calls on behalf of the client instead of expecting the client to make all of the calls like REST does, which means better performance. And GraphQL clients don't have to worry about overfetching or underfetching. So again, you get exactly what you asked for in your response. And it's language agnostic. So while the GraphQL request itself had that kind of structure I showed you, you can implement that in any language you want. So if you're a front-end web developer, might be like maybe like JavaScript, or if you're kind of like doing, you could even do it in like Python if you're doing like really data-intensive stuff. You can do it in like Java or C++, anything like that. There's a GraphQL client kind of implementation for that. And on the server side, it's also language agnostic. So again, since GraphQL has that structure that returns JSON, any object that can generate JSON is, or any language that can generate JSON is a language that works with GraphQL on the server side. It's also really strongly typed. So if you're using, whether you're using an object-oriented language or not, GraphQL itself, again, it's like structured like a graph. So everything has like a type and everything can be mapped really easily. There's also built-in documentation with GraphQL. I think documentation is underrated. It's like, especially in industry, if you're coming into a code base that has existed for like years, like before you even were born, sometimes depending on what company you go to, documentation is so important to get a gist of what the code is doing without having to sit there and just like straight up read code or like debug everything. So GraphQL has built-in documentation that kind of helps you not have to worry about writing documentation for the API. And then there's no versioning. So this one I briefly mentioned how like in like HTTP or like REST APIs, if you want to update an API, you have to kind of release a new version. So like the business's endpoint or that part of the API, if I wanted to update that, let's say I want you to pass in like the business ID and the business's like, I don't know, maybe there's like another way to identify the business, then I would have to release a new version of the API to like deal with that. And that can cause a lot of like breaking changes if a client doesn't handle that well. So with GraphQL, there's no versioning. GraphQL itself will deal with like if anything's weird, it'll like mold the data back to what the client is used to and what the client is expecting. So there's that. And then how Starbucks uses GraphQL. So we're going to revisit this picture again, and you can see, looking back at this homepage, the APIs used to gather all of the data being displayed are actually all REST APIs. So the engineers who develop the mobile app have a lot of places to grab data from, which can get very overwhelming. So we kind of wrap this all up in a GraphQL API. So the orchestra team here at Starbucks, which is the team I'm on, provides our iOS and Android engineers and our web engineers with a single GraphQL API that takes away all of the extra work that comes with consuming REST APIs. So we implement our GraphQL server to call all the other APIs and kind of mold the data for a way that is kind of useful to the client. And the client doesn't even know what like specific APIs we're calling. It just knows, hey, I want to know the person's name and how many stars they have. GraphQL, using GraphQL, we will say, okay, we got to call loyalty, we got to call user info, whatever. And then we, clean the data up, make it look nice, even have some like translations in there, like if depending on what locale the user's in. So for example, there's like Canadian French, if they're like in Quebec or something, we'll also kind of do that to make sure we're calling the right API, make sure we're using the right language, and then return that all to the client in just one simple call. So yeah, that's kind of the end to this. It's kind of an abrupt ending, but there's a lot of info there. So yeah, I guess I'll move into questions now. If you have any questions about anything in this presentation or just about life as a software engineer or about Cal Poly Pomona from what I remember at least, yeah, I'd be happy to answer any questions. Feel free to, yeah.
Oh, wait, you hear me? Should I walk up?
Huh?
Can you hear me from here or should I walk up?
You can walk up.
Okay. All right. So you mentioned like Starbucks and like Yelp uses like GraphQL. Are nowadays do like most companies like industry like use GraphQL to like for all their APIs?
Yeah, I think GraphQL is like kind of a slow riser. I know like a lot of people are like, what's the point of GraphQL? I can just call the database or call the APIs myself. But I think GraphQL is getting used by a lot more companies. I know, for example, Airbnb, they're like really into GraphQL. So if you want to work at Airbnb and you have GraphQL on your resume, that'll look really good. So there's a little tip there. But I think kind of like the companies that are stuck in their ways aren't really like using GraphQL. But the ones that are kind of like, I guess like not newer, but just not as like stuck in their ways and are like more willing to use it. And they'll probably start with like a small team and then it kind of starts slowly spreading, which is how it is at Starbucks. Like the orchestra team started as a small team that only served the web developers. But now both our like mobile app is using it. We have like a new like in-store tech that's going to be using it. So yeah, I think it's slowly taking over because again, everything's mobile. You don't want to have to like wait for every single field when you're not even going to use like 80% of them. You're only going to use like this much data. So I think GraphQL makes a good case for itself. I know they have like a conference every year too. Like the GraphQL became like open source and like split from Facebook. So it still has like a lot left in it, I think. Yeah, I see some questions in the chat. So I'll take a look at that. I see one. So since REST APIs require versioning and Starbucks wrapped three of them in one, or three of them in their GraphQL API, does that mean every time a REST API gets a new version, you have to update the GraphQL too? Yeah, so we do have to update it, but it's in a way that the client doesn't even notice most of the time. So for example, let's say we have, let me think of a good example here. For example, so I'm working on the new kind of point of sale device we're working on. And so that's what's used by the baristas in the store. And one feature that we recently had was the ability to pay with your Starbucks like app where you like scan and you can use like either your Starbucks balance or like a credit card or Venmo, anything you have in there. And before like the API, we were using like the V1 of the API, which wasn't able to distinguish between a Starbucks gift card and then your Starbucks membership card. So I didn't know there were all these different cards, but there are. So a gift card is like the classic one you get like at the store, you like load it up at the grocery store, give it to someone. Your Starbucks membership card is the one that has like your stars that you earn associated with it, like your name is on the card, it's all fancy. So now, so before we would just say like Starbucks card, like if you scan it, it will come up as like Starbucks card. But now the API behind the scenes was updated to be able to distinguish between a gift card and a Starbucks rewards card. And on the server side, or like the GraphQL side, we just say like the name's not going to say Starbucks card anymore. It'll say like Jim's gift card or like Mora's rewards card. Like, and the client itself didn't have to change because the name was coming from GraphQL already, and we just updated it to be more detailed. And there was no like change on the client side. We did have to do work to like update that and do the logic there, but there was no like major version change. Like, oh, clients, you got to update so that you can see the new name. It was like all in place. So hopefully that answered that question. Next one. What APIs do you think are really important to know for the future? GraphQL, of course. I think GraphQL, but of course your common REST APIs, those are never going to go away, I think, especially if you want to work at like a more like traditional or like established company. They're all using like REST APIs. There is RPC, which is another kind of like API or I guess like data transfer protocol. And I know Google has their own, which is called gRPC, which I think is kind of open source. So if you're like interested in Google, maybe learn gRPC and see what you can do with that. But if you know like REST APIs, how they work, I think you'll be good in terms of like software engineering and like, you know, developing, whether that's developing APIs or like consuming them as a client. REST, if you know what REST is, I think you'll be good. And other things will come with time. Another one, with subscriptions, are you able to control the rate of connection with the database? That is a very good question. So with subscriptions, it all depends on the server side. It's like the database itself. The people who are on the database side will set up, expose kind of the subscription, and it has like a little less flexibility there. So they'll be able to say like, we're using like Postgres, for example, or like MySQL. We're going to allow this many connections at one time. And like, yeah, this is like the rate of connections or whatever. Like you can kind of configure that on the like server or like database side. And then the client will just say, okay, I'll like connect to this. And like every time, like for example, let's say like you're trying to track the number of likes a post has and you want to update it in real time, you'll just you'll expose that like database like column or whatever and allow like this many like not like connections, but like it's just kind of like a push kind of situation where this data will get like broadcasted whenever there's a change. And like, yeah, so as like a server side developer, you do have to like consider like the rate of connection and things like that. But if you're just like using the data, the beauty of GraphQL is that you just say, hey, I want to get the likes whenever they're updated. And then it gets more complicated on like the actual database connection between GraphQL. I haven't worked with subscriptions that much, but so subscriptions are more like listeners to the times the server broadcasts. Exactly. Yes. So it's kind of more like a listener, like a subscribe and then broadcast situation. And then if you're using subscriptions, you'll get that data without having to ask for it. You don't have to like poll. You might have heard of polling, which is where you make like a get request like every 10 seconds or something. With a subscription, you're not making like every 10 seconds a request. It'll just get broadcast to you whenever it's updated. So yeah, definitely look into subscriptions. I haven't had a chance to use them a lot, but I know they're very cool and they're very powerful. So yeah, any other questions? No? Do you have any resources that you suggest to learn more from? Yeah, I would say like of course the generic answer is like YouTube or whatever, but I GraphQL is used by a lot of companies, and there's even this one company called like Apollo, which is like trying to standardize the way GraphQL APIs are made. So I think like Apollo, if you just search Apollo GraphQL, they have really good like workshops and like resources and tutorials and like interactive things you can do to learn about GraphQL and kind of master that. Yeah, thank you for sending the link in the chat. So that's in the chat. Yeah, that one we use it at Starbucks a lot too. Like when we're like when we were learning it, we partnered with the Apollo people. And yeah, they're super awesome. They have really good docs, really good documentation. And I would also say another one that if you've heard me talk before, I always say hackathons. I absolutely love hackathons because companies go there to show off like their tools that they spend all their money and time developing, and you can get one-on-one like tutorials on how to use these tools, and you're getting like a first look, and like it's just like a really unique place to like try things without any fear, like, oh, am I going to break something, or like, oh, am I going to get a F because this is a class? Like, no, they're here to like give you free access to all kinds of tech, and you get to just use it. And I think it's super underrated. You get free t-shirts, you get free food. It's just like the best place to learn stuff. And you can try to win a prize if you want, but I would just go to just learn and like meet people. And if I won, cool. I didn't really win anything, but still, I think hackathons are super underrated. So beyond just like online interactive tutorials, go to all the hackathons you can. I really miss going to them. As an industry person, it's hard to go to them. So while you're a young student, go to hackathons and don't be worried about winning stuff. Just go to the workshops, do like the events where you like meet people from companies and get free shirts and whatever. So that's what I would say. And cool. I think we're right at time. So
Yes, thank you, Laura.
awesome. Thanks for having me, everyone. Hope you have a good rest of your day. All right. Bye.
Bye bye. Thank you. You're always